standard deviation, and variance. Another important question that we want to answer about data is regarding its spread or dispersion. Roughly speaking, the population standard deviation, sigma, tells us the average distance that data falls from the mean. The population variance, sigma squared, is the square of the population standard deviation. So how do we find the variance? The variance is the average of the squared differences of the data values from the mean. If capital N represents the number of values in a population with mean mu, and x sub I represents each individual value in the population, then the variance is found by the following formula. The population standard deviation is found by square rooting the variance. Most of the time, we are not working with the entire population. Instead, we're working with a sample. The sample variance formula looks very similar to the population variance formula. However, instead of subtracting the population mean, mu, from each data value, we subtract the sample mean, x bar. And instead of dividing by the population number, capital N, we will divide by the number in our sample, minus 1. We subtract 1 to make up for bias. This is directly related to degrees of freedom for our sample. The sample standard deviation is found by square rooting the sample variance. Now let's look at some examples. Example 1. A statistics teacher wants to decide whether or not to curve an exam. From her class of 300 students, she chooses a sample of 10 students and their grades are given below. Find the mean, variance, and standard deviation for this sample. If we're doing this by hand, our work would look like this. X bar, our mean for our sample, would be 72 plus 88 plus 85, 81, 60, 54, 70, 72, 63, and 43, all summed up, divided by 10. And that gives us an average of 68.8. Now the variance for this sample would be the sum of the differences of each sample data with the sample mean squared, and then we'll divide by n minus 1. And we'd repeat this for each data value, ending with 43 minus 68.8 squared. And then again, we're going to divide by 1 less than the number in our sample, which would be 9. This value will be approximately 199.7. The standard deviation for the sample will be the square root of this value, which will be approximately 14.13. And when we have large data sets, of course, doing it by hand can be quite time consuming. So let's look at doing this on the TI-84 as well as RStudio. On the TI-84, I've entered my list into L1. Now I'm going to quit out of this mode. I'm going to go to Stat and calculate our one variable statistics. My list is L1, and then I'm going to select Calculate. Now notice that we have an S sub x and a sigma sub x. The S is assuming that this is a sample. The sigma would be calculated assuming that this is a population. Since we're working with a sample, our standard deviation is 14.13. You can see our one variable statistics also gives us the mean, the sum of my values, the sum of the squared values, and a plethora of other information that we'll get to later. Using RStudio, enter your list using the C command in parentheses. Make sure you give your list a name. Again, as we learned in an earlier section, the mean is found by the mean command with the name of your variable. Standard deviation command is just SD, like that. And if I wanted to find the variance, I would have to square this standard deviation. So I can type in 14.1327 squared, or I can do SD for standard deviation of the grades and come out here and do caret 2 for squared, and that gives me my variance. Now suppose that the statistics teacher decides to curve the grades by adding 10 points to each score. What is the new mean, variance, and standard deviation? Let's look at our list again on the TI-84. I want to add 10 to each value in the list, but I want to do this without having to retype all my values. So what I'm going to do is I'm going to scroll over here to L2. I'm going to go up to where the name of L2 is and hit enter, and I'm going to say that L2 is equal to L1 plus 10. And what this is going to do is take every value in L1 and add 10 to it, and now I have my new list. Now I want to calculate the mean and standard deviation. I showed using the one variable statistics under calc. If I were to do this, I'd need to make sure that I change my list to L2. There's our new mean, 78.8, and our new standard deviation is the same as the original, 14.13. Now, one other way to calculate if I only wanted the standard deviation is under list, hit second, stat. If I go over to math, we do have a standard deviation command. So we could scroll down to that. And we have a variance command. We can also just click 7. And again, my new data is in L2. There's my standard deviation. So we can see that the mean has changed. In fact, the mean is 10 more than my old mean. So again, this is my old mean, which is 68.8 plus 10. My variance and standard deviation have not changed. So my variance is still approximately 199.7, and my new standard deviation is approximately 14.13. Now this should make sense that the mean changes and our standard deviation and variance do not. Remember, these two values are calculations of spread. All I've done is take my values and shift them all to the right by 10, added 10 points to everything. So there's no difference in the spread or dispersion of my data values. However, their mean has increased. So we can see from this example that adding the same value to all elements does not affect the variance, nor does it affect the standard deviation of a data set. But what about multiplying? Example 3. Let's look at a new data set, and we'll keep it small. And we want to find the variance and standard deviation for this data. Then we're going to multiply everything by 2. And see what's happened to our new variance and new standard deviation. We could do this by hand. I've given you the mean is 4.5, or we can use the calculator or RStudio. Using RStudio, I've entered my data into a list called X. Let me just verify the mean is 4.5. The standard deviation of X is 1.87. And the variance is 3.5. So what happens if we're going to multiply everything by 2? Well, let's create a new list called Y and make it equal to 2 times X. Now the mean of Y is double the value of X's mean. The standard deviation of Y is 3.74, which is double the standard deviation of X. Our variance for Y is not double, but 4 times the variance for our value of X. So let's write this down. Our standard deviation for this set was 1.87 approximately, and our variance was equal to 3.5. When we multiplied everything by 2, our new mean became 9. Our new variance was 14, and our new standard deviation was 3.74. This value is 2 times the original mean. This value is 2 times our original standard deviation. However, the 14 is from 2 squared times our original variance. So generally speaking, when we multiply each value in our data set by some number, our mean and our standard deviation values will be multiplied by that same number, and our variance is that number squared times the old variance. Sometimes we want to compare the variation between two groups. The coefficient of variation can be used for this. The coefficient of variation is the ratio of the standard deviation to its mean. A smaller ratio will indicate less variation in the data. Example 4. The following statistics were collected on 2 different groups of stock prices. The data is organized in the chart below. What can be said about the variability of each portfolio? Well, let's calculate the coefficient of variation for each of these portfolios. For portfolio A, my coefficient of variation is my standard deviation divided by my mean. That gives me a coefficient of variation of 0.123. For portfolio B, standard deviation is 2.95. The mean is 49.80, and we have 0.059 for that coefficient of variation. There is less variation for portfolio B.